So let's start at this end of the section. So I think your section is going to end up somewhere near Fort Lewis here. And if we think about what the topography is doing, we've got a sort of hill, and then we've got something which is sort of flattish, and we've got the fault is coming somewhere here, thrust fault here, and we've got different formation here. So what we have SCL here, then we get into let's say SCY, then we've got SK here, then we've got a dip of 20 degrees towards the southeast, so we can draw that here. Then we've got what is that, DHL, and you can see that there's a 30 degrees towards the northwest here, so we've got DHL is here, 30 degrees towards the northwest. Then we've got SK again. We have a dip of 20 degrees towards the southwest. Then we've got DHL again, and then we have the other formation. So we get into the youngest. So that dark blue is DRI here. So you can see that something that initially looked, that may have looked complicated initially, is actually quite simple once you've drawn these things and you've drawn your construction marks. What's happening here, we've got DHL here, so the base of DHL, the contact between DHL and SK is here, and then it's dipping in that direction, and then it's dipping in that direction. So what we have is a little syncline here, and then that contact is coming over here, and then is going down here, and then we've got an anticline and another syncline. Here we have the top of DHL here, coming here, going in the air, and probably coming somewhere around here. SK, again, is going to start here, and come here, but it's not exposed here, so the SK must go down this way. And the SCY is going to do something similar. So this is what we have here. Obviously, you can draw something a bit tidier than I've done, because this is a whiteboard on a wall, and it's not easy at all, but this is what we have in this area. So keep in mind something that people typically do. They will make the contact too steep, because their pencils are not thin enough to represent that. If you look at this area, the maximum dip is 30-35 degrees. So make sure that you don't end up with massive trough. You're going to have to make your pencil trace coming and just coming very close to the surface, and come in and out and in again this way. And the same will apply to SCL. So SCL is the one that causes problem, because when you look at, this is where you can constrain the thickness of SCL. When you look at the dip of the beds over there in the northwest corner of the map, you will see that the beds are nearly vertical here, and it will be very difficult to make your SCL much thicker than 3, even potentially more than 4 millimeters. So here you've got a bed that is 4 millimeters thick, and it covers massive parts of the landscape. And here, for example, if you want to make your SCL less than 4 millimeters thick, you're going to have to make it come here, here, and what's going to happen is going to have to follow the topography and do something like that. So what we have here is an anticline that is capped by this SCL. You can see in this area, the dip, when you get close to the fault, is around 30 degrees here, so you can draw your dip at 30 degrees here, and then it's going to come over and create that anticline. So this SCL seems to be quite resistant to erosion, because as you will see when you go to the other side, it's going to also cover a large part of the landscape. So it seems to form this sort of cap rock that is very hard to erode and makes the top of the topography in a lot of places, in a lot of hills and even valleys. So that's for that part of the section.